Hi and welcome back to Free Science Lessons. By the end of this video, you should be able to describe the structure of the carbonyl compounds aldehydes and ketones. You should then be able to name aldehydes and ketones. And finally, you should be able to describe the structure of the carbonyl group. Now, we looked at aldehydes and ketones in the Year 12 Organic Chemistry topic. In this video, we're going to be taking a closer look at the structure of aldehydes and ketones. Let's start by looking at aldehydes. I'm showing you here the aldehydes methanol, ethanol and propanol. Now, the first thing to notice is that all aldehydes contain an oxygen atom double bonded to a carbon atom. Scientists call this the carbonyl group, and we can see the carbonyl group here. In the case of aldehydes, the carbonyl group is always found at the end of the carbon chain. Now, if we look at ethanol and propanol, we can see that the carbonyl carbon is also bonded to one hydrogen atom, and this is true for all the aldehydes. However, there is one exception, which is methanol. In methanol, the carbonyl carbon is bonded to two hydrogen atoms. To name an aldehyde molecule, we first identify the longest chain of carbon atoms. This will form the stem of the name. For example, in the case of propanol, the longest chain is 3 carbon atoms, so the stem is prop, which we extend to propan. We then add the suffix al to give the name propanol. And in the case of aldehydes, the carbonyl carbon is always numbered as carbon number 1. I'm showing you here the structural formulas of these aldehydes. In the structural formula, the aldehyde group is shown as CHO. Okay, let's look at ketones. I'm showing you here the ketone propanone. Just like aldehydes, ketones also contain a carbonyl group. However, in the case of ketones, the carbonyl group is always bonded to 2 other carbon atoms. Also, in ketones, the carbonyl carbon atom is never bonded to a hydrogen atom. Okay, I'm showing you here another ketone molecule. Now, when we name a ketone, we have to consider the position of the carbonyl carbon atom. First, we find the longest carbon chain. This will form the stem of the name. In this case, the longest carbon chain has 6 carbon atoms, so the stem will be hex, which we extend to hexane. We then identify the position of the carbonyl carbon. In this case, the carbonyl carbon is carbon number 2. Finally, we add the suffix -one, giving us the name hexane 2-one. Notice that we number the carbonyl group to give us the lowest possible number. Numbering from the leftmost carbon atom puts the carbonyl group at position 2. If we started from the rightmost carbon atom, then the carbonyl carbon would be position 5. However, hexane 5-one would be incorrect, as the carbonyl carbon has not been given the lowest possible number. I'm showing you here the structural formula of hexane 2-one. Notice that in ketones, the carbonyl group is represented as CO. And we could also write a shorthand form of the structural formula like this. I'm showing you here the aldehyde propanol and the ketone propanone. Remember that with aldehydes, the carbonyl group is always assigned carbon 1, so we don't need a number. Normally, a ketone would require a number to show the position of the carbonyl group. However, with propanone, the carbonyl can only be on carbon 2, so a number is not required. If the carbonyl group was on either of the other carbon atoms, then this would be the aldehyde propanol. Okay, we're going to finish now by looking at the structure of the carbonyl group. I'm showing you here the bonding taking place in the carbonyl group. Notice that the carbon to oxygen double bond consists of a sigma bond and a pi bond. The pi bond is formed from the sideways overlap of a 2p orbital from both the carbon atom and the oxygen atom. Now, a key idea you need to understand is that the double bond in the carbonyl group is polar, and I'm showing you that here with propanol and propanone. That's because the oxygen atom is more electronegative than the carbon atom. This means that the electron density in the double bond is shifted towards the oxygen atom. This gives the oxygen atom a slight negative charge and the carbon atom a slight positive charge. Now, this means that carbonyl compounds can react with nucleophiles via nucleophilic addition, and we'll be looking at nucleophilic addition reactions of carbonyl compounds in a later video. In the next video, we look at the oxidation of aldehydes.